In the warm, shallow waters of the Indo-Pacific, beneath the swaying coral and the shimmer of tropical light, something is watching. It has been waiting, patient, precise, and in the blink of an eye, faster than you can even register it, it strikes. This is the mantis shrimp, and it is one of the most extraordinary creatures this planet has ever produced. At first glance, the mantis shrimp looks almost too beautiful to be dangerous. Its body shimmers with colors so vivid they seem almost unreal. Electric blues, neon oranges, and deep purples, like a work of living art moving through the reef. But don't let that beauty fool you. The mantis shrimp is a predator of extraordinary ability. It is capable of delivering a strike so fast and so powerful that it generates cavitation bubbles, tiny implosions of superheated steam that reach the temperature of the surface of the sun. Scientists have described it as one of the most complex and capable predators in the entire animal kingdom. Divers have nicknamed it the thumb splitter. And for anyone who has ever underestimated one, they only make that mistake once. There are over 450 known species of mantis shrimp found in tropical and subtropical marine habitats across the world. But they all share one thing in common: a body built from the very first molecule for violence, survival, and sensory mastery. Today, we're going to find out exactly what makes this creature so remarkable, from the physics of its punch to the mysteries of its mind. Let's start with what the mantis shrimp is most famous for: the single fastest and most powerful strike of any animal on Earth. The mantis shrimp punches using a pair of specialized appendages called dactyl clubs. These aren't like human fists, they are sophisticated biological weapons engineered by millions of years of evolution. Here's what makes the punch extraordinary. The mantis shrimp cannot generate enough speed using muscle power alone, so instead, it has evolved a spring latch mechanism similar to a crossbow. Deep inside the arm, there is a saddle-shaped structure, a biological spring. The mantis shrimp contracts its muscles slowly, storing elastic energy in this spring. When it's ready, a latch releases and all of that stored energy is unleashed in an instant. The result is a punch that travels at over 23 meters per second or 80 miles per hour, accelerating at up to 10,000 Gs. For comparison, a bullet from a gun accelerates at around 1,000 Gs. The force generated can exceed 1,500 newtons, enough to shatter aquarium glass, enough to break a human finger, enough to crack open the hard shell of a crab or snail in a single blow. But the punch itself is only half the story. When the dactyl club moves this fast through water, it creates a phenomenon called cavitation. The water can't fill the vacuum left by the moving appendage fast enough, and tiny bubbles form in its wake. These bubbles then violently implode, releasing a shock wave, a flash of light, and a burst of heat reaching nearly 8,000 degrees Kelvin. This means that even if the mantis shrimp misses, its prey can still be killed or at least stunned by the force of the implosion alone. Engineers have studied the mantis shrimp's club extensively. Despite absorbing thousands of high-speed impacts over its lifetime, the club almost never breaks. Its internal structure, made of a spiral arrangement of fibers called a Bouligand structure, dissipates crack propagation in every direction, making it one of the toughest biological materials ever discovered. This design is now being used to inspire next-generation body armor and impact-resistant materials for aircraft and vehicles. The mantis shrimp has been punching its way through evolution for over 400 million years, and it shows. If the mantis shrimp's punch is its most famous feature, its eyes may be its most astonishing. We humans have 3 types of color receptors in our eyes, allowing us to see what we call the full spectrum of visible light. We think of ourselves as having excellent color vision. The mantis shrimp has 16 types of photoreceptors. The mantis shrimp can see deep into the ultraviolet spectrum and far into the infrared. It can detect multiple forms of polarized light, something no other animal on Earth is known to do with such sophistication. For years, scientists assumed this meant the mantis shrimp experienced the world in an almost unimaginably rich tapestry of color, that it saw colors we cannot even name or conceptualize. But here's where things get truly fascinating. Research has revealed that the mantis shrimp's visual system doesn't actually process color in the same way we do. Rather than mixing colors together to compare and analyze the way our brain does, the mantis shrimp appears to use its 16 photoreceptors as a kind of rapid scanning system, instantly categorizing what it sees. It's less like a painter blending colors and more like a barcode scanner, reading information in parallel at incredible speed. This means the mantis shrimp doesn't necessarily see more than us in the way we might imagine. Instead, it processes visual information in an entirely different way, one that may allow it to make split-second decisions about prey, predators, and mates in a fraction of the time it takes our brains to even begin analyzing what we're looking at. Its eyes are also capable of independent movement. Each eye can swivel in its own direction, allowing the animal to watch for threats behind it while simultaneously targeting prey in front. In the world of the reef, where life and death can hinge on a millisecond, having eyes this advanced is not a luxury, it is a weapon. Beyond its weapons and senses, the mantis shrimp has a life one that is surprisingly complex and deeply territorial. Most species of mantis shrimp are solitary and fiercely so. They dig burrows in the sand or inhabit crevices in coral rock, and they will defend these homes with extraordinary aggression. Intruders are met with threat displays, a spreading of the body's vivid colors, and if that doesn't work, they're met with the club itself. Interestingly, when 2 mantis shrimp of the same species face off, they often engage in what researchers call ritualized sparring, tapping each other's tail shield, called the telson, in a kind of regulated contest. This allows disputes to be settled without either animal risking serious injury. Scientists believe this behavior hints at a level of strategic thinking the mantis shrimp is assessing its opponent before committing to full combat. And when it comes to reproduction, the mantis shrimp surprises us again. Many species are monogamous, forming long-term pair bonds and sharing the same burrow for years. Both parents often take turns guarding the eggs, aerating them with their bodies to ensure proper oxygenation. For an animal so often described purely as a killing machine, this tenderness is unexpected. It reminds us that evolution shapes not just weapons, but entire lives. There are 2 broad guilds of mantis shrimp, smashers and spearers. Smashers, like the famous peacock mantis shrimp, use their clubs to bludgeon our prey like crabs, snails, and clams. Spearers have sharp, barbed appendages designed to impale soft-bodied prey like fish, ambushing them with a lightning-fast stab. Both are supremely effective. Together, they have carved out ecological niches across coral reefs, mudflats, and open ocean floors worldwide. The mantis shrimp is not just a marvel of nature, it is a treasure trove for science, engineering, and medicine. Its dactyl club, as we mentioned, has inspired new classes of impact-resistant materials. Researchers at the University of California, Riverside spent years studying the helical fiber structure of the club, and their findings have directly informed the design of more resilient helmets, aircraft panels, and protective padding. Its visual system has inspired breakthroughs in medical imaging technology. Because mantis shrimp can detect circularly polarized light, a type of light that cancer cells reflect differently from healthy cells, engineers have developed cameras based on the mantis shrimp's eye that can potentially detect cancer earlier than existing imaging methods. Scientists are also studying how the mantis shrimp processes visual information so rapidly, with the hope that its neural strategies could inspire new algorithms in computer vision and artificial intelligence. A system that can identify and categorize objects at biological speeds using minimal computational resources has obvious value in robotics, autonomous vehicles, and surveillance. In short, this creature that evolved on the reef floor over hundreds of millions of years is now helping us build better armor, detect cancer, and design smarter machines. It arrived at solutions we are only just beginning to understand. There is a temptation when we talk about an animal as extreme as the mantis shrimp to reduce it to its superlatives: the fastest punch, the most photoreceptors, the most dangerous thing on the reef. But that would be missing the point entirely. The mantis shrimp is a window into what life can become when evolution is given enough time, enough pressure, and enough freedom to experiment. It is a reminder that the natural world is far stranger, far more inventive, and far more intelligent than we tend to give it credit for. It does not punch to show off. It does not see in 16 colors to our astonishment. It simply lives as completely and as brilliantly as any creature on this planet has ever lived. And somewhere right now, in a patch of sun-warmed coral in the Indo-Pacific, one is watching, waiting, ready. A sniper in the shallows, a jewel of the deep, the mantis shrimp.